Hi and welcome back to Gaffy's Grinds. This is video 6 in our series on atoms, elements in the periodic table. You should know the rules by now. Close any extra unnecessary tabs that you have open, your social media, stick your phone on do not disturb mode, and most importantly, the things that I ask you to do, things I ask you to write, the questions I ask you to practice, you should do these, otherwise you're not going to learn very much. Okay, so without further ado, we'll get jumped in and we're going to start by quickly revising a couple of questions from the previous lesson, because if we don't practice this and recap this and make sure you know this before we jump in today, then today's lesson is going to be much harder. So pause the video and do the questions now. Okay, so you should only be listening to my voice if you have paused and done the questions. A reminder that if you do not do the questions, then you are not going to learn very much at all. Okay, so what do you find within the nucleus of an atom? In the nucleus, we find protons and neutrons. So you should have said protons and neutrons. So I'm only writing down the key things you should have in your answer. You should have a full sentence and either tick it if it's right or fix it if it's wrong. What charge do the electrons have? Electrons have a charge of -1 or a negative charge. Again, you should be writing a full sentence, but the key thing is that you say -1 in your sentence. What is meant by the atomic number? The atomic number tells us the number of protons an atom has. Okay, key thing, number of protons. Again, if you do not have full sentences here, you should have full sentences. You should not just be writing down what I have. I'm only giving you the key part of it. What is the atomic number of carbon? So for this, you would need your periodic table, and you will need your periodic table today throughout the lesson. The atomic number of carbon, you should have said 6. Well done if you said 6. If not, take a look again. If you said 12, then that means you're looking at the wrong number on carbon. You're looking at the atomic mass. So that means you're not clear on the difference between the atomic mass and the atomic number. The atomic number is the smaller of the two numbers an element has. How many protons does an atom of lithium have? Well, lithium's atomic number is 3, so it has 3 protons. Well done if you said that right. Again, if you said 7, then you're looking at the wrong number. Why are carbon and lithium not in the same group? Carbon and lithium are not in the same group because they do not have similar properties. They do not have similar properties. So that's why elements get put into the same group, is if they have similar properties. So carbon and lithium do not have similar properties. Lithium is a metal, carbon is a non-metal. So in fact, they are very much not anything alike each other. So very different properties. So they belong in different groups. How many electrons does an atom of aluminium have? Well, we know that an atom has to have the same number of protons and electrons. So to work out the number of protons of aluminium, I would look at its atomic number, which is 13. So aluminium would have 13 protons. If it has 13 protons, it should have 13 electrons. So well done if you got that right. If you didn't, if you said 27, then again, you are looking at the wrong number. If you said 14, then you're doing it wrong. You're taking the atomic number from the mass number, and that will give you the number of neutrons, not the number of electrons. So hopefully we're clear on those rules that we learned the last day. All right, we're ready to get on with today's lesson. Today's lesson is about drawing atoms. So first of all, we know about protons, neutrons, and electrons. We know how we work them out. We learned how to draw the general structure of where these things are in an atom. But I want you to think back to the diagrams we had for a second. I'm going to just quickly refer back to them. So here is some protons in the nucleus of an atom. And joining them in blue now is going to be some neutrons. Here are some neutrons, and all of this is making up the nucleus of an atom. Now, we said that the protons and the neutrons are in the nucleus. We know that already, but there's something that we don't know. And that is this: when I drew the electrons, we showed them in these shells or orbits. We said the electrons are drawn as like X's, or they could be drawn as dots. It doesn't really matter. And they are found in these shells. And sometimes I would have drawn an atom with like 2 electrons in what we call the first shell, and like 6 electrons in like the second shell. And then I might have had a similar atom like this. I'm just going to copy this one. copy and paste it over here. And now I can add some more electrons. So say I could also have an atom that has a few more electrons than that. So for instance, this one on the left has 2 electrons in the first shell and it has 6 electrons in the second shell. And say, for example, this one had 2 electrons in the first shell and only 4 electrons in the second shell. So the question is, why does the first atom have 2 in the first shell? So 2 here and 6 here. And this one has 2 here and 4 here. Why is it not? Why can we not draw it like this? So instead of having the 4 in the outer shell here, why could it not be like this, where we have, get rid of some of those? Why can we not have like 4 in here and 2 in here? Why is that not allowed? Well, to help us answer that, we're going to have to actually learn some rules about how we need to draw these electrons when we're drawing an atom. Okay, so we're going to practice by drawing an atom. And we're going to begin by drawing an atom of lithium. Lithium is just here on the periodic table, as you can see. So we need some information. If we're going to draw the atom, we're going to need to know how many protons, neutrons, and electrons it has. Now, we're especially interested in the number of electrons because that's what we're drawing in these shells. So I know that lithium has 3 protons because its atomic number is 3. Now, if it's an atom of lithium, then it has to have the same number of electrons as it does protons. So lithium will also have 3 protons. So that's the first thing to think about when we're drawing an atom. We're going to say lithium. First thing to know is we've got 3 electrons. Key information, 3 electrons. Now, I'm going to be sharing with you 3 rules for drawing atoms. The first rule is that we begin by writing down the symbol of the element in the middle, lithium. Now, I know that there's a nucleus here and that the nucleus has 3 protons and 4 neutrons. We know how to work that out. So we're just going to leave that out of these diagrams. We know that lithium in the middle is the nucleus, 3 protons, 4 neutrons. What we're interested here is showing the electrons. So what I'm doing here is I'm drawing the first circle around the lithium nucleus, which is what we call the first shell. And now I'm going to tell you about rule 1. Rule 1. Now just listen, don't be trying to copy down everything. I will give you a chance to write down the rules in a couple of minutes. Just listen to me now while I explain. The first rule is that the inner shells, or the inner shell, what we call the first shell, which is the one I've drawn here. The inner shell of the first shell holds or takes a maximum of 2 electrons. Maximum amount it can hold is 2. So I'm going to draw 1 electron and 2 electrons. That is now a full first shell. I cannot put any more there. So that's rule 1. The first shell can hold 2 electrons. That's the first rule. Now that's not all my electrons done yet though, because I know I've got to get 3 electrons and I've only drawn 2. So my atom isn't finished yet. But I can definitely not put, I'm not allowed to put another electron here. I cannot do that. So I need another rule. Rule 2. Rule 2. Sorry, that's not very tidy. Rule 2 is that you have to fill up inner shells first. Now, why is this? You will find out when you study leave-insert chemistry, okay? There's a very important reason for this, but I'm not just going to tell you now. So when you get to leave-insert chemistry, you'll figure out why do you have to fill up the inner shells first. But for now, just bear with me while I show you how this works. So here, I'm going to draw a lithium atom, and as you can see, I have to have 3 electrons. Now, if I was to say I put 1 electron in the first shell, and well, I need to have 3 altogether. So now in the second shell, I'm going to put 2 electrons. That's a total of 3. Grand, done, job done. No, this is wrong because it breaks rule 2. Rule 2 says you must fill up inner shells first. So the inner shell, or the first shell, is not full in this diagram I've drawn because it can hold 2. I have only drawn 1 in there. So the correct way to do this would be to put lithium in the middle, draw the first shell, and add 2 electrons. It's now full. So the third electron is in the second shell. So this here, this is correct. Okay, now I'm going to get you to pause, and you can take down what I've done there, rule 1 and rule 2, in your notes. So pause and take that down for me now. Okay, so you should only be watching if you've paused and taken down rule 1 and rule 2. We're now going to look at a third rule, but for this, we're going to need to look at a different atom because we need to see rule 3 in action. We're going to need an atom that's got more electrons. So we're going to take phosphorus. Phosphorus is another element. It has the symbol capital P. So I want you to pause the video, find out how many electrons does phosphorus have. Okay, so you should only be watching if you use your periodic table to work out how many electrons phosphorus has. Okay, if you didn't do it now. Okay, so you should have worked out, hopefully you got that phosphorus has 15 electrons. Because its atomic number is 15, so it has 15 protons. If it has 15 protons, it has to have 15 electrons. Right, let's think about how we would draw this then. Well, I'm going to need to give you rule 3 here. Rule 3. And what rule 3 says is that the second, third, fourth shells, and so on, shells can take or hold a maximum of 8 electrons. Now, no, rule 2 still applies. You still have to fill the second shell before you can start filling the third shell, and you have to fill the third shell before you start filling the fourth shell. But these shells can hold a maximum of 8 electrons. So let's check this out then. How would we draw? Well, we've got our P in the middle, phosphorus, to show us what element it is. We then draw the first shell of electrons, which can hold how many? It can hold 2. Okay. The second shell, then I'm going to draw the electrons in. Now, sometimes you'll see the electrons in full shells being drawn as pairs of electrons. Okay, so that's fine. It's not technically wrong to draw them as singles, but I'm going to show you how people usually draw them as pairs. Okay, so you basically draw, like when I say a pair, I mean 2 by side like that. Okay, and then we would have 2 over here, side by side like that. Now, how many can I fit in the second shell again? So speak your answer on 3. 1, 2, 3. Hopefully you said 8. So I've got 2 more pairs to go, like that. Okay, so obviously this here is the second shell, and I'm showing you rule 3. Rule 3 is now got its maximum number. It's got 8 electrons, so it cannot fit any more into shell 2. So I've got to start shell 3. Again, notice how I filled up shell 1 and 2 before I started putting any into shell 3. Now we have to work out how many are left to go in to shell 3. Well, I've got 2 in the first shell and I've got 8 in the second shell. So altogether that's 10. So that means that there are 5 left, because remember there have to be 15 altogether. I've already put 10 into the first and second shell, so I've got 5 left. So I'm going to put a pair, that's 4, and a single, like that. Okay, so that is rule 3 in action. Okay, now I'm going to draw, okay, so what I'm going to do actually is I'm going to get to pause and take that down as rule 3. Okay, what I'm going to do now is I'm going to draw 2 atoms, but I'm going to draw them with mistakes. And I want you to be thinking as I'm drawing, I'm not going to say anything while I draw, I'm just going to draw. When you see me make a mistake, I want you to, speak it out to the screen. I want to say, there's the mistake, there's the mistake. And I want you to think about what rule have I broken? Okay, so think about rule 1, rule 2, or rule 3. Which rule am I breaking? Okay, here I go. Phosphorus, by the way, has 15 electrons. Just so you know, that's what I'm drawing here. Okay, did you spot the mistake? Okay, hopefully you noticed that it is wrong. Which rule have I broken? Well, I've probably kind of broken 2 rules here. I've broken rule 2 because I did not fill up the inner shell first. This shell is not full. So before I filled up shell 2, I started filling shell 3. So I mainly broke rule 2. Well done if you said that I broke rule 2. I suppose I broke rule 3 as well because I haven't shown 8 electrons in the second shell. But rule 2 is the more important one there. Okay, I'm going to do another one. I'm using phosphorus again, 15 electrons. What's wrong with this? Okay, is this right? Is it wrong? And what is wrong if it is wrong? Okay, it is wrong. Hopefully you notice that it is wrong. It's still got 15 electrons. So I have accounted for the 15 electrons, but there's a problem. I've broken rule 3. Rule 3 says that second and third shells can take a maximum of 8 electrons. In the second shell here, I have drawn 13 electrons. So I did not fill it up and then move to shell number 3. Okay, if you were able to spot their mistakes, then that's good. That means you understand the rules. Okay, I am going to ask you now to have a go at one for me. I'm going to help you get started. So you have a go at this one. We're going to do the element calcium. Okay, so first of all, I want you to pause the video, find out how many electrons calcium has, and then press play. Calcium has 20 electrons. Well done, if you got that right. If not, then you still have a problem with figuring out what numbers mean what, and you should go back and watch that video again. So 20 electrons in calcium. All right, let's get started drawing. Okay, I'm going to draw the first shell for you. We've got Ca, and I'm drawing the first shell, and we've got 2 electrons in the first shell. I need to get to 20 electrons. I want you to pause the video and finish off drawing that atom for me now, please. Okay, so hopefully this is what you had. So we've got 2 in the first shell. We're then going to start the second shell. We're going to start filling. The second shell can hold a maximum of 8, and I must fill it up before I move to the next one. I'm going to draw them in pairs. So there is 8. So altogether, I've got 12 electrons drawn. Oh, sorry, 10 electrons drawn now. So I can move into another shell. How many have I got left to do? I've got 10 drawn, so that means I've got 10 left. Well, again, I can put 8 electrons into the third shell. That gets me to 18. I'm not finished yet. I need 20 electrons. So I'm going to draw a fourth shell, and I'm going to put that final pair in the fourth shell. That's 20 electrons. Have I obeyed all the rules? Yeah, I've got 2 in the first. I've got a maximum of 8 in the second and third. I haven't drawn any more than 8. And I've made sure to fill up the inside ones before I've moved to the next one. So that is correct. Well done. You're ready to do some practice by yourselves. Okay, so got quite a nice bit of practice for you here. Again, there's a lot to do in here, but if you really want to master this and remember it and be able to do it forever, then it's really important that you practice these and don't skip over them. Don't just draw one and say that's enough. It's not. There's enough in here to practice all the different skills, different sizes of atoms, different amounts of electrons. So do put the effort in now. Pause the video and you will learn this properly and you'll get really, really good at this. And that's what we're interested in. So pause the video, draw these atoms now. Okay, right, ready to go. Now, here is the first one. We've got nitrogen with 2 in the first shell and 5 in the second shell. Oxygen would have 2 in the first shell and it has a total of 8 electrons. So it's got 6 in the second shell. Well done, you got that right. The next one is helium. Helium, He, has only 2 electrons altogether. So helium has 2 in the first shell. That's it. Well done. If you got those right, excellent. Good job. Neon. Let's check neon out. Neon has got 2 in the first shell and it's got a total of 10. So that means 2 in the first shell and it's got 8 in the second shell. That's neon. Sulfur, S, has 2 in the first shell and it's got 16 altogether. So I'm going to have a full second shell. That gives me 10 and it's got 6 left. So in the third shell, it's got 1, 2, 3, 4, 5, 6. You'll notice something here. I want you to spot a pattern. Compare sulfur and oxygen for me. They're in the same group in the table. Look at the group in the table. They're both in group 6. Do you spot any pattern there? Well, we'll be looking at that pattern in the next video. If you're able to spot a pattern there, then that's really impressive. I'm going to keep going. Next one, aluminium, Al. Al got 2 electrons in the first shell. It's got 13 altogether, so it's got 8 electrons in the second shell. And it's got 3 left. 3 electrons in the third shell. There we go. Aluminium. Let's take a look. The next one is silicone. Si, silicone. Okay, so silicone, oops. We've got 14 electrons altogether. We've got 2 in the first shell. We've got 8 in the second shell. And we've got 4 in the third shell. Altogether, that gives me 14, which is correct. Let's check the next one, carbon, C. 2 in the first shell. 1, 2, 3, 4 in the second shell. Next one is lithium, Li. 2 in the first shell and 1 in the second shell. 2 left to do. Sodium, 2 in the first shell, 8 in the second shell. Sodium has 11 electrons altogether. That's 10 drawn so far, so it's got 1 more and it goes into the third shell. The next one is potassium, symbol K. 2 in the first shell, 8 in the second shell. Now let's stop and check. We need to get, for potassium, we need 19 electrons altogether. Its atomic number is 19. It's got 19 protons, 19 electrons. So I've drawn 10 so far. I've got 8 in the third shell. That gets me to 18. And finally, 1 more in the fourth shell. That gets me to 19. So check yours now. You should have all of those correct. So check, make sure you haven't broken any of the rules. If you follow the rules, this should be pretty straightforward, pretty easy to do. Okay, and you are now well on the way to being able to draw models of the atom. Okay, now like I told you in the very first video when we talked about atoms, is that nobody really knows exactly how atoms look like. We just use these models. And obviously, they're much smaller than this, and we don't have these electrons that are just sitting fixed on these rings. These electrons are whizzing all around the nucleus, going crazy, following these really fast paths that they go around. This is just a model to help us understand the structure of the atom. Now, the whole rules of the 2, 8, 8, and so on, those are there for a reason. We do know stuff about electrons that make us believe that they are in these kind of what we call energy levels, or that they orbit in this kind of arrangement. 2 are close to the nucleus, 8 are a bit further away from the nucleus, then another 8 are a bit further away from the nucleus. It's not like we're just making it up just for the sake of doing something to do with the atom. We do have reasons why we believe that there's 2 in the first energy level, 8 in the second energy level, and so on. So it's like, while we're not sure about anything to do with the atom because we can't see them, we're using our best collection of evidence to put together a model, and this is what it looks like. Okay, now again, it's always going to be, the more you learn about chemistry, the more this model will advance, but this is the most basic one. Okay, all right, so you now know how to draw the electrons in an atom. In the next video, we're going to look at we're just going to take a closer look at the patterns of electrons in each shell and what those patterns kind of mean. Okay, so that's what we'll be doing in the next video, and I'll see you then. One more thing, guys, I suppose, if you found the video useful, if you found it pretty easy to understand and pretty easy to follow, then if you could like the video, it would really help the channel. It would help other people to find it, and it could help more students learn how to do this in an easy way. Okay, all right, thanks, guys. See you in the next video.